This is part 5 of section 3.4. Solving logarithmic equations using the one-to-one properties, okay? If a logarithmic equation can be expressed as a single logarithmic term equal to a single logarithmic term. So I have a log equal to a log, no plus one, nothing else. So basically, when I end up with something like this, a log equal to a log, and they have the same base, our one-to-one property, which is what I'm saying you're going to use here, you can set the arguments equal to each other. Now, it is important that you have the same base here. They will throw problems at you where you do not have the same base. Okay, so we have to double check that before we can use this property. But if you do, then that's going to be the way that you go. All right? So look at this problem here. I do not have a single logarithm equal to a single logarithm. Okay? So what I'm going to do is I'm going to try to get there. And if I think about the properties of logarithms, here these are both natural logs, so meaning they have the same base, which is e, so I'm allowed to use all of my properties for them. I can combine these, and our property says that I should multiply these together. So I have natural log of x plus 5 times x plus 1, and this is equal to natural log of x minus 1. Okay, so now I have a single logarithm equal to a single logarithm. They have the same base. So using the one-to-one property, I can drop the logs and set the arguments equal to each other. So I have x plus 5 times x plus 1 is equal to x minus 1. Now, this is going to give me a quadratic that I need to solve, so I need to multiply this out and then get a 0 and solve it from there. So if I distribute combine like terms here, I end up with x squared plus 6x plus 5 is equal to x minus 1. Now I'll move all of this over to here. I have x squared plus 5x plus 6 is equal to 0. We can factor this as x plus 3 times x plus 2 equals 0. And from this one, I would get that x equals negative 3. And from this one, I would get that x equals negative 2. So I have two potential solutions. I need to check them both. If this is going to require that I take a natural log of a negative number, this answer has to be thrown out. So if I take the negative 3 and I plug it in, for this argument, I would get a positive 2, which is okay. But right here, negative 3 plus 1, that's going to give me negative 2. So I have to throw this one out because it would require that I take a logarithm of a negative number. If I check negative 2, here, it would be okay. But again, here, I would have a negative number. So this one has to go away as well. Now, it is important that you understand that you can have many potential solutions, but there's no way of knowing until you check how many of them, if any of them, are going to be good. Okay, so it's not like I throw away a negative 3 and the other one must work. You can have them all not work, they could all work, you just have to check. But since these were my only two possible solutions and I had to throw them both out, the answer to this is no solution. It's the empty set. There is no number that will work for this. Okay. Now I sort of used this up here already, but often we're going to have to condense things down so that we can get either a single logarithmic term, period, in which case we can change to exponential form and solve, or condense things down, simplify it down to where we can have a single logarithm equal to a single logarithm, because those are the two ways we have to solve these things. Okay, and also sometimes we're going to have to use the change of base formula because we have to have the same base before we can combine anything. let's solve this equation. If I have log base 3 of x minus 8 plus log base 3 of x, I want this to equal 2. Both of these have base 3, so that means I can use my properties and combine them. These are added together, so I should multiply these arguments. I'll have log base 3 of x times x minus 8. It might help you to put those in brackets right now just so that you recognize that all of this belongs to this. And this equals 2. Okay, so now that I have a single logarithm equal to a number, I can switch this to exponential form. So this comes over here and it becomes 3 squared. So I have x times x minus 8 is equal to 3 squared is 9. Okay, now I need to distribute here because I will have a quadratic to solve. And I have x squared minus 8x is equal to 9. Subtract 9 from both sides so that I have my 0. And this will factor as x minus 9 times x plus 1 is equal to 0. This one would give me that x equals positive 9. This one says I would get a negative 1. Now let's check these to see if they work for my domain. If I take a 9 and plug it in here, I'll have log of 9 minus 8 is 1, and we're allowed to have an argument that's 1, so that's good. And this is just x, and that's positive, so 9 works in both of those. It is a solution. Negative 1. I don't even have to do the arithmetic here because it definitely does not work here. So I have to throw out negative 1. Your only answer on this problem is 9.